Welcome to the Deep Dive. Today, we're going to be exploring black box testing techniques.
Ooh, sounds interesting.
It's like, trying to figure out how to crack a safe.
Okay.
You know what it's supposed to do.
Right.
But you've got to figure out the combination by trying different inputs.
Okay.
Without knowing the mechanics inside.
I see.
Our source material for this deep dive is a document called blackboxtestingtechniques.pdf.
Okay.
And by the time we're done here, you'll have a solid understanding of these techniques.
Gotcha.
And how they're used in software development.
Awesome.
Yeah.
That's a great analogy because in black box testing, we're evaluating software solely based on its inputs and outputs.
Okay.
We don't peek at the code or any of the internal workings.
Yeah.
It's just like someone trying to open a safe without knowing its mechanism.
So if I'm trying to log into a website, black box testing would be like me trying different username and password combinations to see if I get access.
Exactly. You're focused on whether the login functionality works as expected, regardless of the code behind it.
Okay, I'm starting to see the value in this.
Yeah.
Let's get into the techniques. What's the first one we should unpack?
So first up is equivalence partitioning.
Okay.
Imagine you're testing a field for a user's age, which must be between 18 and 65.
Okay.
Instead of testing every single age, you divide the input data into groups or partitions that should behave similarly.
Okay.
So you might test 17 invalid, 25 valid, and 66 invalid.
So the idea is that if one value within a partition works, you assume all values within that partition will work.
Yes.
It's like a shortcut to make sure the software is behaving as expected.
Precisely.
Right.
And this is particularly useful when you have a large input range but limited testing resources.
Right.
It helps you prioritize your testing efforts without compromising coverage.
That makes a lot of sense. But how do we decide on the right partitions? What if we miss a crucial edge case?
That's where our second technique comes in.
Okay.
Boundary value analysis, or BVA.
Okay.
It focuses on testing the boundaries of these partitions where errors are most likely to occur.
So going back to our age example,
right,
we'd also test 18 and 65 since those are the edges of our valid range.
Exactly. Think of it like stress testing a bridge.
Yeah.
You want to make sure the supports at the edges are strong enough to handle the load.
Okay, that's a vivid image.
Yeah.
It seems like these two techniques work well together.
They do.
What's the next technique in our black box testing toolkit?
Let's move on to decision table testing.
Okay.
This is all about systematically mapping out all possible combinations of conditions and their expected outcomes.
Okay.
Think of it like a flowchart where each decision point leads to a different outcome.
So if I'm ordering a pizza online, the decision table might include choices like crust type, toppings, and delivery method. And each combination should result in a specific order confirmation.
Precisely. You're outlining all the possible scenarios to ensure the software handles each combination correctly.
Gotcha.
This is especially useful when you have complex logic with multiple conditions affecting the outcome.
It sounds like this technique is essential for avoiding those, wait, I didn't order anchovies moments.
Exactly. It helps prevent those unexpected surprises and ensures a smooth user experience.
Okay, on to technique number 4.
All right.
What have we got?
Now we have state transition testing, which focuses on how an application moves between different states.
Okay.
Think of a traffic light. It goes from red to green to yellow.
Yeah.
And each transition has specific rules.
Right.
We want to make sure the software follows these rules flawlessly.
So for the website login, the states might be logged out, logging in, and logged in.
Exactly.
And we need to ensure that each transition, like entering the correct password to go from logging in to logged in, happens as expected.
Exactly. This technique is crucial for applications that involve a sequence of steps or states, like online shopping checkouts or multi-step forms.
I can see how this would be really important for making sure users don't get stuck in a transition loop or end up in an unexpected state.
Right. We want to make sure the flow is seamless and intuitive for the user.
Okay.
Now let's talk about use case testing, which really focuses on that user perspective.
Okay, tell me more about that.
Sure.
This sounds like it could get really interesting.
With use case testing, we're testing real-world scenarios to see if the application meets user expectations. Imagine you're testing an e-commerce website.
Yeah.
Your use cases might include browsing products, adding items to a cart, and completing a purchase.
So it's less about individual components and more about testing the whole flow of how a user interacts with the software.
Exactly. You're putting yourself in the user's shoes and ensuring the application meets their needs effectively.
Okay, that makes a lot of sense.
Good.
So far, we've covered techniques that seem very structured and systematic. Is there room for intuition in black box testing?
Absolutely. That's where our final technique comes in error. Guessing.
Okay.
This relies on your experience and knowledge of common software vulnerabilities to anticipate potential problem areas.
So it's kind of like a detective using their knowledge of past cases to predict the culprit's next move.
That's a great analogy. It's about leveraging your understanding of the software, common coding mistakes, and user behavior to uncover hidden bugs that might not be caught by other techniques.
I like that it adds a human element to the process.
Yeah.
But if we're not looking at the code, how do we know if our error guesses are on the right track?
Well, that's where things get a bit more interesting, and we'll dive deeper into that in part 2.
Sounds good to me. We've covered a lot of ground in part 1.
We have.
We've unpacked the core concept of black box testing and explored 5 key techniques: equivalence partitioning, boundary value analysis, decision table testing, state transition testing, and use case testing.
We sure have.
But there's still more to discover.
Right.
So stay tuned for part 2, where we'll delve into the intricacies of error guessing.
Okay.
Look at real-world examples and discuss how to choose the right technique for the right situation.
Looking forward to it.
Welcome back. Before we went to commercial, we were just starting to talk about error guessing and how our intuition plays a role in black box testing.
It's a fascinating aspect of testing because it brings in the human element.
Yeah.
It's where your experience and knowledge of software development really come into play.
So it's not just about blindly guessing.
Right.
There's a method to the madness.
Exactly. Think about it.
Okay.
You've probably encountered certain types of errors or vulnerabilities in the past. Maybe you've seen how specific inputs can cause unexpected results.
Right.
Error guessing is about using that knowledge to anticipate potential weak points in the software.
Okay. I'm starting to see how this could be a powerful tool.
Yeah.
But could you give me a concrete example of how error guessing works in practice?
Absolutely.
Okay.
Let's say you're testing a form that asks for a user's email address.
Okay.
Using error guessing, you might try entering an email address without the @ symbol or with an invalid domain name.
Okay.
You're essentially anticipating common mistakes that users might make and checking if the software handles them gracefully.
So it's like preemptively catching those typos and slip-ups before they cause problems for real users.
Precisely. It's about proactively identifying those gotchas that might trip up the software.
Okay.
Another example could be testing file upload feature. You might try uploading a file that's too large or a file type that's not allowed.
I see.
Yeah.
It's about thinking like a mischievous user.
Right.
Trying to find those edge cases that could break the system. But doesn't this approach rely heavily on the tester's experience?
It does, but...
What if you're a newbie to software testing?
That's a great point. While experience definitely helps, there are resources available that can guide your error guessing efforts.
Okay.
For example, there are lists of common software vulnerabilities and testing checklists that can give you a starting point.
So even if you don't have years of experience, you can still learn from the collective wisdom of the testing community.
Absolutely. There's a wealth of knowledge out there to tap into.
Okay.
And over time, as you gain more experience, your error guessing skills will become even sharper.
Okay. That makes sense.
Good.
Now we've covered all 6 techniques.
We have.
It's quite a comprehensive toolkit.
It is.
But in the real world, how do we decide which technique to use for a particular situation?
That's where the art of testing comes in.
Okay.
There's no one-size-fits-all answer.
Right.
But there are some guidelines to help you choose the most appropriate techniques.
I'm all ears.
Okay.
You give me the inside scoop.
Well, first you need to consider the nature of the software you're testing.
Okay.
Is it a simple form or a complex web application?
Right.
The complexity of the software will often dictate which techniques are most suitable.
So for a simple form,
yeah,
we might focus on equivalence partitioning and boundary value analysis to cover those essential input ranges.
Exactly.
Okay.
But for a more complex application, like an e-commerce platform, we'd probably need a combination of techniques.
Yeah.
We might start with use case testing to ensure the core user journeys are working smoothly.
Oh.
Then we could layer on decision table testing to handle all those different scenarios with multiple conditions.
It sounds like it's all about adapting the techniques to the specific needs of the project.
It is.
But what about time constraints?
Oh, yeah.
In the real world, we don't always have unlimited time for testing.
That's a crucial consideration.
Yeah.
Time is always a factor in software development. That's why it's important to prioritize your testing efforts based on the risks involved.
So if a particular feature is critical to the application's functionality,
yes,
we'd want to invest more time and effort in testing it thoroughly.
Precisely. You need to assess the potential impact of a failure,
right,
and allocate your testing resources accordingly.
Okay.
For high-risk areas, you might use a combination of techniques to ensure maximum coverage.
Right.
For lower-risk areas, you might opt for a more streamlined approach.
Okay, I'm starting to see the strategic thinking involved in black box testing.
Yeah.
It's not just about running tests.
Right.
It's about planning, prioritizing, and making informed decisions.
Well said.
Okay.
It's about finding the right balance between thoroughness and efficiency.
Right.
But speaking of running tests, let's shift gears a bit and talk about how we actually put these techniques into practice.
Okay, let's get into the nitty-gritty.
All right.
How do we go from abstract techniques to concrete actions?
The key is to translate those techniques into test cases.
Okay.
Step-by-step instructions for executing a specific test.
So it's like creating a recipe for testing a particular aspect of the software.
Exactly.
Okay.
A test case outlines the inputs, the expected outputs, and any specific conditions or steps involved.
Right.
It's a blueprint for conducting a controlled experiment with the software.
Okay, I'm following.
Good.
But where do these test cases come from?
That's a good question.
Do we just pull them out of thin air?
Not quite.
Okay.
The test cases are derived from the techniques we've discussed.
Okay.
For example, if you're using equivalence partitioning,
right,
your test cases would focus on testing values from different partitions.
So the technique provides the framework.
Yes.
And the test cases are the specific actions we take within that framework.
Precisely. The techniques guide the creation of the test cases, ensuring that we're covering the most important scenarios.
Okay, I'm starting to get a clearer picture of how all these pieces fit together.
Yeah.
But once we have our test cases, what happens next?
Wow.
Do we just start clicking buttons and hoping for the best?
Not exactly.
Okay.
There's a process involved in executing those test cases and analyzing the results.
Okay.
And that brings us to the fascinating world of test execution and reporting.
All right, I'm ready to dive into that world.
Okay.
But I think we'll save that adventure for part 3.
Okay. Sounds good.
We've covered a lot of ground in this segment. We've delved into the nuances of error.
Okay.
Guessing, discussed how to choose the right technique for the job, and explored the concept of test cases.
Right.
But there's still more to uncover, so stay tuned for the final part of our deep dive, where we'll wrap things up and leave you with some key takeaways to apply to your own software testing endeavors. Welcome back to the final part of our deep dive into black box testing. We've explored the techniques, talked about choosing the right approach, and even touched on creating those detailed test cases. Now let's talk about putting those test cases into action and what happens after the tests are run.
Right. We've laid the groundwork, and now it's time to see those plans come to life.
Yeah.
Executing those test cases is where we really get to see how the software behaves under different conditions.
So walk me through it. What does the actual process of test execution look like?
Well, it can vary depending on the complexity of the software and the resources available.
Okay.
Sometimes it's as straightforward as manually stepping through each test case, providing the inputs and observing the outputs.
So it's like following a recipe, carefully measuring each ingredient and watching to see if the cake rises properly.
Exactly. You're following those test case instructions meticulously and comparing the actual results with what you expected to happen. But for larger applications or when we need to run tests repeatedly, we often turn to automation.
Automation. That sounds like it could save a lot of time and effort.
It does.
Tell me more about that.
There are tools specifically designed to automate test execution.
Okay.
These tools can run through those test cases much faster than a human can, and they can even generate reports that highlight any discrepancies or errors.
So it's like having a robot chef that can bake hundreds of cakes simultaneously and tell you exactly which ones came out perfectly and which ones need adjustments.
That's a great way to put it.
Okay.
Automation is all about efficiency and consistency.
Yeah.
It frees up human testers to focus on more complex or exploratory testing tasks.
Okay, so we've executed our test cases either manually or with automation.
Yeah.
What happens next?
Well,
we've got all this data about how the software performed. What do we do with it?
That's where test reporting comes in.
Okay.
This involves documenting the result of your tests, including any defects or issues that were uncovered.
Right.
A good test report will provide a clear and concise summary of the testing process, the findings, and any recommendations for next steps.
So it's kind of like presenting your findings to the software development team, highlighting any areas that need attention.
Exactly. Think of it as a feedback loop that helps the developers understand how the software is performing and identify areas for improvement.
Okay. I can see how that would be invaluable for ensuring the quality of the software.
Yeah.
But we've talked a lot about finding and fixing bugs. Is that all there is to black box testing?
That's a crucial part, but it's not the whole story.
Okay.
Black box testing also helps us validate that the software meets user requirements and expectations.
Right.
It's about ensuring that the software is not only functional, but also user-friendly and fit for its intended purpose.
So it's not just about making sure the code works. It's about making sure it works well for the people who are actually going to use it.
Precisely. It's about taking that user-centric perspective and ensuring that the software delivers a positive and seamless experience.
Okay, that makes a lot of sense. As we wrap up this deep dive, what are the most important things you want our listeners to remember about black box testing?
Well, first remember that black box testing is a powerful tool for ensuring software quality, even if you don't have access to the source code.
Okay.
It's all about understanding the inputs, the outputs, and the expected behavior of the software from the user's point of view.
It's like evaluating a restaurant based on the quality of the food and the service without needing to know the chef's secret recipes.
Exactly.
Okay.
And second, remember that there's a whole toolkit of techniques available from equivalence partitioning to error guessing.
Right.
The key is to choose the right techniques for the specific software you're testing and the goals you're trying to achieve.
And don't be afraid to get creative with those techniques. Mix and match them, adapt them to your specific needs, and always be on the lookout for those sneaky edge cases.
Absolutely. The world of software testing is constantly evolving, so stay curious, keep learning, and don't be afraid to experiment.
Well said. We've covered a lot of ground in this deep dive. We've explored the core concepts, the key techniques, and even the practical aspects of test execution and reporting. I hope you found this journey insightful and that you're feeling equipped to apply these principles to your own software testing endeavors. And as always, we encourage you to share your thoughts and questions. What resonated with you? What are you still curious about? Keep the conversation going and let us know what you'd like to dive into next. Until then, happy testing.